Picture this. A tiny spacecraft, no bigger than a grand piano, hurtling through the darkness at 36,000 miles per hour. It's been traveling for nearly a decade, crossing billions of miles of empty space, all to visit a world that most people had written off as irrelevant, a world that got kicked out of the planetary club before this mission even got there. But here's the thing about writing something off too early. Sometimes, just sometimes, the underdog comes back and proves everyone spectacularly wrong. Welcome to the story of Pluto, the little world that could, and the absolutely mind-bending things NASA discovered when they finally got there. Let's rewind to 2006. Pluto had just been demoted. After 76 years of being the quirky ninth planet, the astronomical community essentially said sorry, not sorry, and downgraded it to dwarf planet. Kids everywhere had to relearn the solar system. Textbooks became instantly outdated. It was astronomical chaos. But here's what makes this story beautiful. In that exact same year, while the scientific community was busy arguing about definitions and categories, NASA did something incredible. They launched New Horizons. They basically said, you know what, we don't care what you call it, we're going there anyway. And thank goodness they did, because what they found changed everything we thought we knew about the outer solar system. Now, getting to Pluto is no joke. We're talking about a world that's so far away that light from the sun takes over 5 hours to reach it. For context, light reaches Earth in about 8 minutes. Pluto is out there in the cosmic boonies, the absolute frontier of our solar system. New Horizons had to be fast, really fast. NASA strapped this relatively lightweight probe onto one of the most powerful rockets available and basically shot it out of Earth's gravitational grip like a cannonball. Within hours, it had already passed the moon. The Apollo astronauts took 3 days to make that journey. New Horizons did it before lunch. But even at those incredible speeds, it still took 9 years. 9 years of waiting, 9 years of checking instruments, making tiny course corrections, and hoping nothing went wrong. Because here's the terrifying thing about space exploration. If something breaks out there, you can't just send AAA to fix it. To compare things, Pluto is a frozen world, open to the vacuum of space for billions of years. I bet the analysis of the images and lighting data from New Horizons would have been fascinating. During those 9 years, scientists could only imagine what they'd find. The best images of Pluto from Earth-based telescopes showed it as basically a fuzzy blob. We knew it was small, we knew it was cold, we knew it had a moon. That was about it. Most people assumed Pluto would be boring, a dead, frozen rock covered with ancient craters floating in the cosmic deep freeze for billions of years with nothing interesting happening. A space potato. They could not have been more wrong. As New Horizons approached in the summer of 2015, the images started coming in. At first, they weren't much better than what we could see from Earth, just a bright dot with another smaller dot beside it. That's Pluto and its companion, Charon. But then something magical started happening. Day by day, pixel by pixel, that dot started to resolve into an actual world. And the scientists watching these images come in started to realize they were seeing something nobody expected. Colors. Lots of colors. See, everyone assumed Pluto would be various shades of white and gray, ice and rock. Boring. But as the images got clearer, they revealed something stunning. Pluto is a painter's palette. Deep crimson reds, pristine whites, subtle blues and yellows, burnt oranges. This thing looks like someone took a cosmic paintbrush and went absolutely wild. And then they saw the heart. Right there, taking up a huge portion of Pluto's face, is this enormous heart-shaped region. It's officially called Tombaugh Regio, named for Clyde Tombaugh, the guy who discovered Pluto back in 1930. But everyone just calls it the heart. And here's where things get really interesting, because this isn't just a cute geological coincidence. This heart tells us something profound about Pluto. This world is alive. Not alive in the biological sense, obviously, but geologically alive, active, changing. The left side of the heart, a region called Sputnik Planitia, is completely smooth. And when I say smooth, I mean unnaturally smooth for a world that's been sitting in a shooting gallery of asteroids and comets for 4 billion years. Think about it. Every world in the solar system gets pelted with space rocks. Our moon is covered in craters. Mars is covered in craters. Even Earth would be covered in craters if we didn't have weather and oceans constantly erasing them. But this giant plain on Pluto, practically pristine. That means something is constantly resurfacing it. Something is erasing those craters almost as fast as they form. This ice isn't just sitting there frozen for eternity. It's moving, flowing, renewing itself. And here's the kicker. That ice is even water ice. It's way too cold for that. The nitrogen mystery. Ice that shouldn't exist. Pluto sits at negative 380 degrees Fahrenheit. That's negative 223 Celsius for the rest of the world. At those temperatures, water ice becomes as hard as rock. It doesn't flow, it doesn't change, it just sits there frozen solid forever. But Pluto's surface is mostly nitrogen ice. Yes, nitrogen, the same stuff that makes up most of Earth's atmosphere, the same stuff in liquid nitrogen that scientists use to freeze things instantly in those cool demonstration videos. Except on Pluto, nitrogen isn't a gas or a liquid, it's frozen solid. And somehow, even at these absurdly cold temperatures, it still manages to flow. Giant glaciers of frozen nitrogen creep down from Pluto's highlands into those smooth plains, carving patterns into the surface that look eerily similar to glacial features on Earth. But it gets weirder. If you zoom way in on Sputnik Planitia, you can see these bizarre cellular patterns. They look like someone drew irregular polygons all across the surface, each one maybe 10 or 20 miles across. These aren't random. They're being created by heat. Yes, heat, on one of the coldest places in the entire solar system. This is where Pluto starts to break our understanding of how small worlds should work, because according to everything we know about planetary science, Pluto should be dead cold all the way through. Here's the basic rule. Big things stay hot longer than small things. A big pot of coffee stays warm for hours. A small cup cools down in minutes. The same principle applies to planets. Earth is big enough that it still has a molten core billions of years after forming. Mars is smaller, so its core cooled down and the planet became geologically dead. Pluto is tiny compared to both of them. It should be frozen solid, but it's not. Pluto found overwhelming evidence that Pluto has a warm interior, maybe even a liquid water ocean beneath that frozen nitrogen surface. Those polygon patterns in Sputnik Planitia are convection cells. Heat rising from below causes the nitrogen ice to slowly churn, creating those patterns. The same physics that creates the cells in your pot of boiling water is happening on Pluto, just imaginably slowly and with frozen nitrogen instead of liquid water. The ice volcanoes tell the same story. And yes, you read that right, ice volcanoes. Sitting on Pluto's surface is a mountain called Right Mons. It's about 3 miles high and 90 miles across. And it's a volcano. Except instead of erupting molten rock like volcanoes on Earth, it erupts a slushy mixture of water, nitrogen, ammonia, and methane. Picture a cosmic slushy machine, except the slushy is poisonous and frozen and erupting onto a world that's already colder than anywhere on Earth. That's Right Mons. And the crazy thing is, it's still active, or at least it was recently, geologically speaking. The volcano is so fresh-looking that it can't be that old. There's barely any impact craters on it, which means it must have erupted relatively recently. Maybe 1 million years ago. Maybe less.
This is supposed to be impossible. Pluto doesn't have a large neighboring planet creating tidal forces to heat its interior like Jupiter does with its moons. It doesn't have radioactive materials in its core like Earth does. So where is all this heat coming from? The answer might lie with Pluto's companion. Charon isn't just a moon orbiting Pluto, it's more like Pluto's dancing partner. At half the size of Pluto itself, Charon is proportionately the largest moon relative to its parent body in the entire solar system. Our moon is big compared to Earth, sure, but Charon is so big relative to Pluto that they don't really orbit each other in the traditional sense. Instead, both Pluto and Charon orbit around a point in empty space between them. It's called a binary system, and it creates some truly bizarre effects. For one thing, they're tidally locked to each other in both directions. If you were standing on one side of Pluto, Charon would hang in your sky in exactly the same spot, never rising or setting. And from the far side of Pluto, you'd never see Charon at all. It would be like having a moon that only half the planet gets to see. But the really interesting thing is what this relationship tells us about Pluto's past. Charon probably didn't form peacefully alongside Pluto. The most likely scenario is that they collided. Two separate objects smashed into each other billions of years ago, but instead of destroying each other or merging together, they ended up locked in this eternal gravitational embrace. And that collision, that would have dumped an enormous amount of energy into both worlds, energy that might still be working its way out of Pluto's interior today, driving those ice volcanoes and keeping that subsurface ocean liquid.
Remember those colors I mentioned earlier? The reds and oranges covering parts of Pluto's surface? There's a fascinating and slightly unsettling explanation for those. They're called tholins. These are organic molecules, meaning molecules containing carbon, that form when ultraviolet radiation from the sun hits methane and other gases in Pluto's thin atmosphere. The radiation breaks apart those molecules and they recombine into complex compounds that happen to be deep red. Then, like radioactive snow, they drift down and coat Pluto's surface. Now, before anyone gets too excited, organic doesn't mean biological. These aren't signs of life. They're just complex carbon-based chemistry happening naturally on a frozen world billions of miles from Earth. But they are genuinely fascinating because they're the same kinds of molecules that might have existed on early Earth before life emerged. Pluto is basically running a natural chemistry experiment out there in the cosmic cold, creating these molecules and splashing them across its surface in striking red patterns. And interestingly, we can see some of that red on Charon too, particularly around its north pole. Scientists think that might be material from Pluto's ice volcano eruptions that escaped into space and eventually got captured by Charon's gravity. Despite being smaller than our moon and having temperatures that would freeze carbon dioxide solid, Pluto has an atmosphere. It's incredibly thin, about 1 million times less dense than Earth's, but it's there. And it does something remarkable. As Pluto orbits the Sun on its elongated, tilted path, its distance from the Sun changes dramatically. When it's closer to the Sun, more of that nitrogen ice sublimates, turning directly from solid to gas and puffing up the atmosphere. When Pluto moves farther away, that atmosphere freezes back onto the surface. Pluto literally breathes over the course of its 248-year orbit. Its atmosphere expands and contracts like cosmic lungs. And that atmosphere creates weather. Sort of. We're talking incredibly slow, incredibly cold weather, but weather nonetheless. Nitrogen snow falls from those thin clouds. Frost migrates across the surface. Hazes form in layers high above the surface, creating this subtle blue glow that's visible in some of New Horizons images. It's a complete, complex atmospheric system on a world that most people wrote off as a boring ice ball.
Here's what makes the New Horizons mission so important. It proved that we were wrong about everything. Not just wrong about Pluto specifically, but wrong about our entire understanding of small worlds in the outer solar system. We thought that once you get past Neptune, everything would be dead, frozen, and boring. Ancient remnants from the solar system's formation just sitting out there in the cold, unchanged for billions of years. Pluto proved that assumption spectacularly wrong. If a world as small as Pluto can be this active, this complex, this interesting, what about all the other dwarf planets out there? What about the thousands of objects in the Kuiper Belt that we've never visited? What about places even farther out? The New Horizons flyby lasted just a few days. The spacecraft came screaming past Pluto at over 30,000 miles per hour, snapped as many pictures as it could, took every measurement its instruments could handle, and then sailed on into the darkness. But those few days of data collection fundamentally changed our understanding of the solar system. You might be wondering why any of this matters. Pluto is billions of miles away. It's smaller than our moon. We can't live there. We can't mine it. It doesn't affect our daily lives in any way. But that's missing the point entirely. Every time we explore somewhere new, we learn something unexpected. Every time we challenge our assumptions about how the universe works, we expand our understanding. Pluto taught us that small worlds can stay geologically active far longer than we thought possible. That means icy moons around Jupiter and Saturn might have subsurface oceans for far longer than we expected. That increases the chances those oceans could harbor life. Pluto taught us that the outer solar system is far more dynamic and interesting than we imagined. That makes future exploration more exciting and potentially more fruitful. And on a more philosophical level, Pluto reminds us that the universe doesn't care about our categories and definitions. We can argue all day about whether something deserves to be called a planet, but the universe is going to do interesting things regardless of what labels we apply. New Horizons is still out there, still traveling deeper into the Kuiper Belt. In 2019, it flew past another object called Arrokoth, giving us our first close-up look at one of these ancient, pristine building blocks of the solar system. And it's still going, still sending back data, until eventually its power runs out and it becomes another silent artifact of humanity's exploratory spirit, drifting through the cosmos. But there are no plans for a return mission to Pluto. NASA's attention is turned to other targets closer to home, the ice moons of Jupiter and Saturn, Mars, Venus. These are all worthy destinations, but it means Pluto will probably remain unexplored for decades to come. Those images from 2015 might be the best pictures of Pluto we see in our lifetimes. And honestly, that makes them even more special. We got one shot at this world, one chance to see it close up, and we discovered something amazing. Pluto isn't a planet, fine. It's a dwarf planet, a Kuiper Belt object, whatever technical term you want to apply. But labels don't change what it actually is, a geologically active, atmospherically complex, surprisingly colorful world that continues to puzzle and amaze scientists. It has flowing glaciers made of frozen nitrogen. It has mountains of water ice as hard as steel. It has ice volcanoes erupting cosmic slushies. It has a subsurface ocean that shouldn't exist. It has an atmosphere that breathes with its orbit. It has organic chemistry painting its surface red. And it has a giant heart right there on its surface, as if to remind us that sometimes the smallest, most overlooked things turn out to be the most interesting. That's the real discovery NASA made at Pluto, not just the specific features and phenomena, but the humbling reminder that the universe is far stranger and more wonderful than we can imagine sitting here on Earth. Every time we venture out to explore, we find something that surprises us. Every time we assume we know how things work, nature proves us wrong. Pluto didn't need to be a planet to be important. It just needed to be itself, weird, wonderful, and absolutely fascinating. And now, thanks to New Horizons, we finally got to see it for what it really is. Not a planet, not a dwarf planet, just Pluto, being Pluto, out there on the edge of everything, quietly doing the impossible. And we got to witness it.